in section 2.5, we're going to be looking at using linear models. For this video, you're going to want to have your calculator out in front of you. We're going to be focusing a lot on doing math in the calculator in this lesson. I'm going to be using a TI-84 for this tutorial. If you have a different calculator, know that most Texas Instruments calculators kind of have the same button, so you might be able to follow along just fine. If you have any questions, though, specifically to your calculator, if it's different, feel free to let me know. In this video, we're going to focus on making scatter plots and finding a line of best fit. So just to recap here, a scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. You can use a scatter plot to determine the strength of the relationship or correlation between data sets. So a correlation coefficient basically quantifies the strength of a relationship between two variables. The closer that you get to 1 or a -1, the stronger that relationship is. And as you can see by this chart, 0 represents no correlation. So if I was plotting those points, I couldn't see any trend here. The closer that I get to 1, it would be a perfect positive correlation. -1 would represent a perfect negative correlation. So we're going to first focus on making a scatter plot in our calculator. And the example problem that we're going to look at here, I have a table that shows the cost of in-state tuition at The Ohio State University over the years. So I'm starting in the year 2000, and I have data ranging all the way up to 2018. So what I'm going to do here is we're going to have our calculator out. I think that when you have this data, seeing an actual picture of that data can be really helpful in making conclusions from there. So that's exactly what we're going to do. So I have my TI-84 out, turn it on, and I'm going to start by pressing Stat and then Enter for Edit. Here I want to have a blank slate to be able to enter lists of data. So if you have any data in any like L1, L2, anything like that, if you go to the top of the list and click Delete, it should get rid of that whole column. So once you have a blank slate to work with, let's type in the data that we've been given. I'm going to use my years as L1 and my cost as L2. And I'm going to type them in like so. For years, I'm going to start at year 0 to represent the year 2000 and go up all the way to 18. In L2, I'm going to type in the cost of tuition just as I see it. Again, just to reiterate, I'm not typing for L1, I'm not typing the years as their actual numerical value. So as you'll see, the year 2000, I represented as 0. Kind of thinking of it like year 0, that's where I'm starting my data from. Then in 2002, that's 2 years after the start. Then 4 years, then 6 years, all the way up to 18 years after the start of my data. From here, I want to get to stat plot. So I'm going to press second y equals to get to stat plot, enter to talk about plot 1. So this is going to help me set up what my scatter plot's going to look like. So the main thing that I want to see in this table, I want to see that plot 1 is on, and the type of graph is going to be a scatter plot. So that's that first option that's highlighted. As you can see in some of the options to the right, I could maybe make a bar graph, maybe make a box whisker plot. I want a scatter plot, so that first option, I'm good to go. I want my X list to be L1 and my Y list to be L2. Everything like you see on this screen is what I want. So from there, I'm good to go. Last thing I'm going to do before I plot this is make sure that my graph is focused in the right area. So from here, I'm going to press Zoom and go down to 9 for Zoom Stat. That's going to make sure that when I actually graph this picture, it's going to zoom in on the plots that I want to see. From there, I'm going to press Enter, and I can see all of my data in a nice scatter plot. So what's cool about this is that now that I see a picture, I can determine the strength of the relationship and make predictions from there. Also, if I press Trace, I can kind of easily go from point to point, and I can see another visual representation of my data. So here I have highlighted the first coordinate, which is x equals 0, y equals 4,383. That responds to my first coordinate. If I press the right arrow, I move over 1, I see 2, and then 5, 6, 9, 1. that corresponds to the year 2002 having a tuition of $5,691. And again, why is this helpful? I can also use this graph to determine a correlation. I can clearly see that there's an upward trend, and all of the data looks like it's almost in a straight line. So I'm going to go ahead and say that there's a strong positive relationship here between year and cost of tuition increasing. Now, what's also going to be helpful here, the second big topic we're going to talk about, is making a trend line. A trend line is a line that approximates the relationship between variables. So basically, it's making some linear equation that goes through the middle of your data. What's helpful about these trend lines is that I'm going to use past data to be able to make predictions about the future, and that's going to be where we end our video today. Sometimes, also before we move forward, a trend line, or the most accurate trend line, is called the line of best fit. And we're going to use the line of best fit or find it in a calculator. Our TI-84s, or our graphing calculator, can digitally find the best trend line that can go through our data the most accurately. And from here, it's kind of tedious entering your data in the first place. Since our stuff's already in L1 and L2, making our trend line from there isn't going to take as much time. From here, I'm going to go back into my calculator. I'm going to press Stat, but now I'm going to move to the right to Calc. And then I'm going to go down to option 8, which is LinReg. From there, I'll press Enter. Everything here looks good. I'm using L1 as my X list, L2 is my Y list. Everything else just leave as its normal settings are. And then press Enter to calculate. And now what's cool here is that it gives us all the data that we need to make our linear equation of line of best fit. So using the format y equals a plus bx, I'm going to use this number as my a value, this number as my b value. So the line of best fit here is y equals 5,662.76 plus 317 plus 0.68x. And the other really cool piece of information that we get from this is an actual value of our correlation coefficient. So I can also say that my R value is 0.93. So this does confirm that I have a strong positive correlation. Last thing before we move on is let's just plot this line of best fit in our scatter plot to see that all the data makes sense. So from here, I'm going to type or press y equals in that top left corner. And I'm going to type my line of best fit just as I see it. And then I'll press graph. And I can see here, just to double check, yeah, that line definitely looks like it goes through the middle of my data. That looks like an accurate trend line. And that is in fact our line of best fit. So finally, to end this video, let's use this equation to make a prediction about the future. So let's predict the cost of tuition when most of you guys might be going to college in 2025. What I'm going to do is I'm going to use my equation, y equals 5,662.76 plus 317.68. X represents my year, so to represent the year 2025, I'm going to type in 25. From there, I plug this into my calculator, and I get the value 13,604.76. So here I can conclude that it's reasonable to assume that tuition in 5 years will be somewhere around $13,604.76. What's also important to note here is that I can't go out there and say as a fact that's going to be what tuition is going to be in 2025. As you know, there's a lot of times very unforeseen circumstances that might affect tuition costs. For example, the coronavirus pandemic, I'm assuming, is going to really affect tuition rates, as there was a steep drop in tuition this year and maybe even for the following years after that. But given the past data that we have, it's reasonable to assume that the value that we just found should reasonably be around what you should expect to pay in that time frame.